The 16th to 18th century is characterized by some rather important events and some important contributors, so that's what we're going to look at now. We've already looked at mobbing, and this is yet another example of that. So you recall it's typically when a smaller bird is harassing a larger bird, usually because it perceives that larger bird as a threat. Well, these are duck decoys. There was a type of technology that was employed around this period in the Netherlands, started out in the Netherlands, and it was captured by an artist and engraver named Hans Boll. So he did not invent this technology, but he's the one who basically reported it to us, especially in some various engravings and artwork that he has left throughout the centuries. And it involves a duck decoy, what was called a duck decoy, but not this kind of duck decoy. So not what you're seeing here. That's the duck decoy of Hans Boll. And so basically what it is, try to point out some features here. Actually, I'm going to go to one of his other drawings. Yes, this one. So these are the kind of things that were drawn by Hans Boll. And I've put that arrow there. The arrow indicates there's a dog. So the way this worked is there's a dog that runs along the side on land, but it's, guess what, mobbed by these waterfowl that just swim into the canal after it until the dog reaches the very end, and then I guess some kind of a net drops down to trap the waterfowl. And so this was one way that they were hunted. Now, in modern times, there are a couple of these that exist. I saw one in England. They're actually used to trap waterfowl, not for hunting purposes, but so that they can be banded and then released in the wild. But it capitalizes on the mobbing response of birds toward potentially threatening animals, and in this case, it's a dog that in reality is not a threat. And so here are some other pieces by Hans Boll. There's the dog right down there. And there's some ducks. And here they are in the waterway. And again, a modern version. So this is the canal back here. There's the dog right there. There's a couple ducks over there. So it capitalizes on the mobbing behavior response of waterfowl toward potential predators. And there they are inside the canal where they can be banded. Okay, this is something that was going on in Italy around the same time, and I don't know who the artist is here. It was not Hans Boll, but in any event, what they've done here, again, as a way of trapping birds, is to put a potential predator on top of this pole, just tether it to the top of the pole, and then wait for it to be mobbed by all of these other birds. Now, what they would do is paint a sticky substance on these various perches, so when the birds landed on it, as they were mobbing this potential threat there, they had a hard time releasing themselves from the perch, and the people would gather them up for whatever reason. I would assume for dietary reasons back then. Okay, so much for mobbing. René Descartes. I mentioned Descartes in this course mostly because he put forth a point of view that is the opposite of Aristotle's vitalism. So you remember when I talked about Aristotle, I was talking about how vitalism is the beginning of the nature-nurture controversy, that being the nature side of the coin. Well, Descartes' mechanism is the nurture side of the coin because he advocated physical laws governing behavior rather than some inborn vitalistic soul-like mechanism.
Think about how it happens. There's some electrical activity in your brain. Your neurons fire, they send a signal down into your nervous system. It passes along down into your muscle fibers, they twitch. You might say reach out your arm. Looks like it's a free action on your part, but every one of those, every part of that process is actually governed by physical law, chemical laws, electrical laws, and so on.
Rather than some kind of inborn soul entity. So this is now the nurture side of the nature-nurture controversy. And we'll be following that throughout various segments. And I'm going to have more to say about that, in fact, in this particular segment. Now, you remember Aristotle's Scala Naturae, great chain of being, and remember that at the very lower portion of his scale are sponges and other formless creatures. But of course, as I mentioned in an earlier segment, there are creatures that are below that in terms of just how you could look at them in terms of complexity. This is not, by the way, an evolutionary relationship by any means. Do not confuse this with an evolutionary tree at all. This is just a scale. And so, finally, we're able to discover those things because of Leeuwenhoek, who invented the first microscope. It may not have been the very first, but it was the one that actually led to some discoveries. And it didn't look anything like that. That's more like a modern classroom-type microscope. No, it looked like that. Very interesting instrument. And you might wonder how you would possibly use something like that. So you used it this way. So notice that you can attach a specimen on the pointy object right there, and then move the specimen by turning this to move it toward the lens. There's the lens, very crude type lens, and you'll see why that's important, why I'm saying it was crude in a few moments. And then you could adjust the focus by turning this knob, which would raise or lower the specimen toward or away from the lens. So that's basically how it worked, and you would have to hold it up to a light source. The light would shine through the lens, and you could then view the specimen at the end. Now, Leeuwenhoek, using this device, did discover some simpler organisms than sponges, protozoa, bacteria, and spermatozoa in those respective years. So this opened up a whole new world of organisms that prior to this time we didn't even know existed. Carl Linnaeus, so again, going back to Aristotle, who you'll recall had a classification scheme, some of which has lived on to this day. But most of it has been actually replaced with Linnaeus's classification scheme. He wrote this book called Systema Naturae, and in it he presents the beginnings of what is basically modern systematic zoology. He put forth his binomial nomenclature, bi as in two, nomial as in name, nomenclature as in classification system. And the two elements are, you can probably already guess that, genus and species. So everything has a genus name and a species name. And of course it can get more complex than that when you start dealing with subspecies and then higher order levels like families and subfamilies, orders and things like that. But basically any given organism can be identified by its genus and species name, its scientific name rather than its popular name. So for example, Ax sponsa, that's the genus, Ax sponsa, the species, that's basically the wood duck. Pan troglodytes, the chimpanzee. Homo sapiens, us. So this is the classification scheme put forth by Linnaeus, the beginning of modern systematic zoology. Getting back to what I was saying about nature-nurture. Okay, preformationism versus epigenesis. Preformationism is kind of what dominated the way people viewed development around this time. Again, we're dealing with the 1600s, 1700s, thereabouts. So people believed that everything was preformed and all that happened is you got bigger as you developed, just mere growth. Everything was already there, as you see in this artistic representation on the left of a fully formed being coiled up inside of a sperm. And then after fertilization, everything is already there. It just gets bigger. Well, that's not the way things really work. And here's another drawing from around this period. It depicts Zeus liberating fully formed creatures from an egg. Basically, it's in the fully formed creatures are in that area. There, we'll look at it blown up like that. And you can see a bunch of fully formed creatures that are coming out of this egg. There's a human, there's a bird, there is an alligator or lizard of some sort. I guess that's some kind of a horse. Looks like a dragon, who knows? Fish, insects, and so on and so forth. Everything is already fully formed. All it has to do is get bigger, thus the term preformation. Another drawing from around this period, in this case 1750, showing the result of putting sperm into a glass of water. There you go. You already have a fully formed being. Development doesn't really work that way. And it turns out one of the culprits into what kept this going, this philosophy going, actually was the microscope. You would have thought that that would have sorted things out. Well, I said earlier the lens was rather crude, and people sort of went into the use of this instrument with the self-fulfilling prophecy. I mean, preformationism was already the dominant way of thinking about development, and so they would use this crude instrument, and they thought they really were seeing fully formed beings because the lens was not all that sophisticated. So they kind of just psyched themselves out into what they already believed, into thinking that that's what they were really seeing. And of course, they weren't really seeing that. They just thought they were. So that did not, at least initially, help clarify what happens in development. Oh, and by the way, preformationism got mixed up with with emboîtement, a French term that means encapsulment, and now the whole religious community gets involved because they're kind of using the combination of preformationism and emboîtement to talk about special creation. In other words, it was kind of a combination of special creation and preformationism, according to which all human generations can be traced back as already having been preformed in the ovaries of Eve. So there's no change, there's no evolution, basically. Everything is already preformed. So now we're dealing with preformationism, which is a developmental concept, and special creation, in other words, a non-evolutionary point of view. You just kind of combine the two, and metaphorically, you can see where emboîtement or encapsulment, everything is already preformed, goes all the way back to the ovaries of Eve. So this was sort of a dominant way of thinking around this time, now that religion gets involved in the whole thing. Well, the opposing point of view is epigenesis. In other words, development is change or differentiation over time, going from a rather generalized state to a state of greater specificity. For example, if we look at this early developed fish embryo, you see that it's very undifferentiated at first, and then a little bit later on it starts to differentiate into various parts, and now we have a head, and we can see the tail at the bottom, and there's an eye, and of course it's going to undergo much further development after this point in time. Or, for example, take another species, a frog, for example. You don't start out with a fully developed frog that only gets bigger. That would be the preformationistic point of view. But no, it starts out as a very generalized egg, and it develops into a tadpole. There's our tadpole. And then it will metamorphose into a frog, as we see coming up. Right there we have a frog. Okay. Epigenesis. So yeah, differentiation from the general to the specific. So here we're looking at a chick embryo, for example. And you can see that there's some very generalized limb buds, little extensions that don't really look like anything, just these little buds. But then a little bit later in embryonic development, you can see that they've differentiated into digits. And here's a film that kind of shows the same thing.
When Tiktaalik was first conceived, like every animal that has ever lived, it started as a single cell, which slowly formed into a body. Small buds appeared, and genes, like Sonic Hedgehog, shaped them into fins. Over millions of years, fins like these evolved into a myriad of forms, like the limb of this early amphibian with 8 fingers. As millions more years passed, new variations emerged, from the clawed limbs of reptiles that would colonize dry land, to the powerful arms of primates that could traverse through the trees. Until eventually, a remarkable piece of anatomy arose that would itself transform the world: the human hand. This history is not just in our bone, flesh, and muscle. It's in our DNA.
Differentiation from a generalized limb bud into very specific parts depending on what species you happen to be. Oh, and by the way, he mentioned Sonic Hedgehog. That's actually the name of a gene that is triggering the differentiation of these limb buds into these different types of body parts, again, depending on what species you are. Nothing's preformed. Epigenesis is what is going on in development. Well, one of the movers behind epigenesis around this time was C.F. Wolfe, who at the age of 26 wrote a book called Theoria Generationis, published in 1759, where he actually did use the microscope, but didn't go into it with a mindset of preformationism, but rather did a very careful analysis of the development of the chick embryo and saw that, yes, there was no little chicken that was preformed in there, but there was rather a very generalized egg-type state that differentiated over time, and ultimately you would end up with a chicken. And so this is sort of the beginning of the epigenetic point of view. Now, Wolfe was very young and pretty relatively unknown in the scientific community. But fortunately, there was another person around who was very well known in the scientific community, Carl von Baer, who gave us a set of laws, and he basically popularized what Wolfe had actually discovered. And so he was advocating, his laws basically center around development going from a very generalized state to a state of greater specificity. In other words, development is differentiation. So there's a group of laws that sort of attest to that. We won't look at the laws individually, but they all boil down to basically that, which is the epigenetic point of view. So von Baer helped popularize the work of Wolfe. And so basically, gradually, epigenesis replaced this outmoded view of preformationism. But in a way, if you look at the nature-nurture issue, preformationism exists today as a form of the nature side of the coin, not the way it did back then. Nobody believes in preformationism today in terms of organisms being fully preformed and all that happens is growth. Nobody buys into that. But if you look at the nature side of the coin, where things are apparently already determined for you prenatally by your genes or whatever, you can see where there's a similarity between genetic determinism, the nature side of the coin, and preformationism, the nature side of the coin, way back when. So that's pretty much a sample of what was going on in this period of time.